Number 9 is taken from the C2 PastPaper Jan 2013 integration question. The finite region R, as shown in the figure 2, is bounded by the x-axis and the curve with equation y equals 27 minus 2x minus 9 square root x minus 16 over x squared, where x is greater than 0. The curve crosses the x-axis at the point 1, 0 and 4, 0. Copy and complete the table below, giving your values of y to 3 decimal places. So in order to complete the table, you need to substitute x in the function. So substituting x in the function will give you y equals 27 minus 2 times 2 minus 9 square root 2 minus 16 2 squared, and you plug it in the calculator and you will get the answer, which is equal to 6.272. Doing the same thing for the value x equals 3, and your answer is going to be 3.634. So we've completed the table in part A. Part B, use the trapezium rule with all the values in the completed table to find an approximate value for the area of R, giving your answer to 2 decimal places. So be careful when you're using the trapezium rule, you are finding an approximate value for the area of the region given. So first let us look at the formula. We have half times h multiplied by u0 plus 2 times u1, u2 till un minus yn minus 1 plus yn. So you can write it as y0 plus yn into plus 2 times y1 plus y2, etc. till yn minus 1. So you can write it in this manner as it's found in the booklet, formula booklet, or you can write it like that. It doesn't make a difference. Now let us on the table identify these variables. So this is A and this is B. This is y0, y1, y2, y3, y4, y5 and y6. And be careful, n is equal to the number of strips minus 1. So the number of strips are 1, 2, 3, 4, 5, 6, 7. So it is 7 minus 1. So n is equal to 6. So now we've identified all the variables. Let us place them in the formula. So h is equal to b minus a over n. So it's 4 minus 1 over 6, which is equal to 3 over 6, which is equal to 1 over 2. So replacing the numbers in the formula, as you see here, as it's shown in this, replacing the numbers here, and then you plug them into your calculator and you get the answer. And be careful, they want the answer in 2 decimal places. Part C. Use integration to find the exact value for the area. Now when you integrate, you are finding the exact value. When you're using the trapezium rule, you're finding an approximation for this value. So you start with changing first square root. So you have to change it. You have to change it into the form that you can integrate. So 27 minus 2x minus 9 x to the half minus 16x to the minus 2 dx. And now you start integrating. 27 becomes 27x, and minus 2x to the 1, you add 1 to the exponent and divide by the new exponent, so it's minus 2x squared over 2. In our case here we have, in this case here we have minus 9, leave space, and then x to the half plus 1, x to the over to the new exponent. Now the new exponent here, it's 3 over 2. So when you have x to the 3 over 2, you're going to divide by the new exponent, which is 3 over 2. So instead of dividing it and writing it like that, which is sometimes confusing, you directly write the reciprocal of this fraction, which is the exponent. You write the reciprocal of it and you say it's multiplied by 2 over 3. So now your new exponent, or the new term, is minus 9 times 2 over 3 x to the 3 over 2. Now why did we do that? It's better for us to think about it in this manner instead of looking at it and having all these fractions over each other. So directly you say that whenever you have an exponent which is a fraction, you leave space next to the x, and then the exponent that you get, you flip it and you write the fraction next to it directly. Plus, working with this one, we have minus, let's do it here, minus 16x to the minus 2. So I need to add 1, so it becomes minus 1, and I divide by minus 1. So actually you're going to have minus divided by minus is plus 16x to the minus 1. And if you're going to change it to a positive exponent, it's 16 over x, and this is what I wrote here. Now be careful, you have to keep the bounds, and then you replace the upper bound instead of x, and then the lower bound instead of also x, and adding them up, you're going to have 12. Now 12 is the exact value for the region R that we have here, the exact value, because you integrated it, and you found the approximation, which is using the trapezium rule, which is 11.42. and as you can see, 12, the number 12 and the approximation are very close to each other.